here's a review of the bearings pieces you need to kind of grapple with here and make sense of. Let's start really straightforward. If you have a bearing of 80 degrees of B from A means that's your starting point. A is your starting point, okay? That's the starting point. So it's that starting point, which is that place of measurement where we're actually going to measure that 80 degrees. All right, in this case, we are going to say, all right, 80 degrees is nearly 90, so I'm going to draw that out, and that is from north, going clockwise always, 80 degrees. Okay? So the bearing of B, let's say this is B here, of B from A is 80 degrees. That's how that looks. Got it? Now what if I wanted to come back and I needed to know the bearing of A from B? B is now our starting point, and we're trying to go back toward A. So again, I have to, though, be coming off of a north, which is parallel to the other north here, right? These have to be parallel. And I'm trying to, again, go clockwise, measure clockwise off of my north. In this case, I'm looking at a obtuse angle, definitely more than 180 degrees even, and something in the neighborhood of almost 270, right? If I do my little crosshairs on here. But how I can calculate that mathematically is I take my 80 degrees from my original point here, and I'm going to add 180 degrees to it. So 260 degrees is this answer here. This is 260 degrees. And that makes sense, right? It's nearly 270. And it is, in essence, a combination of the 180 of this semicircle here. I'm going to shade it in. This 180, which is this, plus this 80 degrees, which is corresponding and is the same measurement as this 80 degrees. That's how we get this problem of 80 plus 180 equals 260. Okay? Let's try this with a different kind of problem, though, because I want you to be able to see it with an angle that is more than 180 degrees. So let's use this example. Suppose I'm given that I have a bearing of B from A that's 200 degrees. So I start always again with my north, and I need to get a bearing of 200 degrees. And in fact, I'm going to draw this over in a different side for a second. So here's my north, 200 degrees. Well, if I do my little crosshairs off of my north, 200 degrees is going to be past the 180, something like that. That's 200 degrees. So far so good, right? Here's my north. Now, to get back from, and again, this is from A, so this is my A, and over here is my B. To get back, I need to draw my north off of the other one, and I'm measuring again only clockwise to the right until I hit that line. And see how that's actually a very small angle here. Here I started with an acute angle, a smaller angle, and ended up with a much bigger return. Here I start with a big initial angle, my return back is small. So what you actually do mathematically on this one is you do 200 minus 180, not plus 180, and you get the answer of 20 degrees. And how that works in terms of the perpendicular lines is this. If I continue this line here, right, then let me change colors so you can see it. This in here, this angle here, is corresponding, is the same measurement as this angle here, isn't it? See that? And this is again my 180. So this whole 200 is a combination of the 180 plus whatever the difference is here. That's why I take the 200, which is the whole thing, subtract just the 180, and I'm left with 20. That's my measurement in here, 20 degrees. It's also my measurement there. Okay? Here's a word problem. A ship travels on a bearing of 50 degrees and then stops. All right, so I'm going to draw my 50 degrees, right? I start always with north. It travels 50 degrees. That's more than half of a 90, right? So if I think about the 90, it's more than half of it, but just a little bit more than half of it. So that's about 50 degrees. Okay. And then it stops. So it stops. Let's say it stops right there. It starts here, stops there. When it stops, so at this point, It is 10 kilometers due north. It is now 10 kilometers due north of a port that is due east of the starting point. So we have some kind of north thing here going on, right? So let me draw a long line here and just be really clear. This is north, and that is parallel, remember, parallel here. And it is now here, when it's here, it is 10 kilometers due north of a port. So there's a port below it, right, due south of it. And the port that is south of this point is due east, exactly east of the starting point. So exactly east of the starting point would be here. So I'm going to close this triangle, and this is the second port, right? Do you see how it is 10 kilometers south of the port? Is 10 kilometers south of the ending point, and it is due east, straight east. So a due north and a due east intersection is always going to be a right angle here. I have a piece of data here that is a length. I have a piece of data here, but that's not inside my triangle, is it? And in order to use trig, I have to know one of the angles inside the triangle. So I have two options. You could just look at this intersection here and say, you know, this is 90 degrees as well. So the remainder of 90, if you take away 50 from it, in here will be pretty hopefully straightforward for you, right? We got that. That's 40 degrees in here. So I can use that. The question that's being asked, we have to find out what our x is, right? Because now I have a value inside we now have a value inside the triangle of 40 degrees. I have a value of one of the sides, and the question's asking, how far did the ship sail? Well, the ship didn't sail due north, or due east, or south. The ship sailed on the 50-degree bearing, so it sailed here, which means this is my variable. That is what I'm trying to solve for. So I can look at that, and I need to decide if this is sine, cosine, or tangent, right? Well, I have the hypotenuse, so I know it's going to be sine or cosine. And looking at this angle, across from it, meaning the opposite side, is the 10 kilometers, so I have a sine function. So I'm going to set that up. So I have sine of 40, and I'm just using trig on the triangle, equals 10 over x, opposite over hypotenuse. And how we solve this kind of problem is you cross multiply. So I have sine of 40 times x equals 10. And then to solve for x, I need the sine 40 to be cleared away. It's being multiplied there, so I'm going to divide both sides by sine 40. And what kind of helps us here is that then x equals, this is what goes in my calculator, right? 10 divided by sine 40, which gives me this. And if I'm going to simplify that, approximately 15.6, and I'm talking about kilometers. So take a look at that. Notice the steps we took. We first made sure we drew a north, right? And we used the bearing. And then we had to figure out which way the triangle was being drawn. Was it being drawn up here, but it was being drawn down here because we had a port south of the ending point. Our ending point, in essence, was north of this port. And the port is due east, exactly east, so that's 90 degrees. And we used our 90 to solve for the 40. And then I identified, right? I knew that this was my adjacent side, this was my opposite side, this was my hypotenuse. That's how I was able to come up with and say, well, I'm going to use my sine, and then solve.